Okay. So we kind of talked about the motivation behind kind of the advent of drivers last time, and probably it being uh, the kind of the rise of networking as being maybe the motivation of this. Today we look at it less about that from a consumer perspective. We look at it as more of the things that are supporting consumers, being graphics cards and new interesting USB type devices that you plug in that have some sort of special needs that came out well after an operating system was released. We started talking about firmware a little bit. What's the advantage of firmware? Like, why does it exist? Well, first of all, what is firmware? So, we say this software for hardware that lives/runs on the hardware. Why does it exist? What does it do? Well, maybe we have to have a differentiating point between software and hardware. What's the difference between software and hardware, besides the word?
Well, hardware is physical. Actual element. And
Okay.
software is what runs on the hardware.
Okay, hardware is tangible. That's an interesting word, right? Tangible. Software exists in bits, so digital space. Oh, that sounds like more professional. Digital space. Okay. Um, what kind of problems does hardware and software solve? Are the problems different?
Not necessarily.
Yeah, not necessarily.
Depending on the problem. Like software will help you store stuff on a storage device.
Okay. So the reality here is we kind of have to go down to a lower level to really understand what hardware is. When we think of hardware, what immediately comes to mind are things like external hard drives and that kind of stuff. There's a differentiating point for that says that's hardware versus our Hello World program that we wrote. Those seem very different. But realistically, let's just use uh, what would be a very simple example? Could you create a piece of hardware that took a 1 or a 0 as input and flipped it to, if it was a 0, it becomes a 1, if it was a 1, it becomes a 0? Could you create a piece of hardware, a circuit, that acted as an inverter? Yeah, we could create a piece of hardware. That's a simple piece of hardware. Send an electrical signal in, input, whatever it is, it inverts it to the other type of, to the output. If you deal with digital zeros and ones, it comes in as a 0, it outputs as a 1. It comes in as a 1, it outputs as a 0. Could you write a computer program to do the same thing? Take an input that is a true and make it a false. Take an input that's a false and make it a true. So at that level, is hardware and software equivalent? I want to drop us down to a really simple problem so we can, analyze the difference between hardware and software. So in that case, if we're doing something that simple, are they equivalent? At least in terms of the problems you're solving. Let's not go beyond that performance or anything like that. But in terms of the problems we're solving, we could solve that one problem either using hardware or using software. Right? Go ahead.
Does the hardware use software to invert?
In that case, it wouldn't.
So
At the most simple level, and I'm just trying to really get it down to a simple level, 0 software is involved. It's like a filter, if you will. You apply electricity here, electricity comes out here, and what happened in the middle just did the inversion crap. Okay? So at that point, there's no software involved. So now you have a problem to solve, and you have to decide, do I solve this in hardware or do I solve this in software? Well, what's the advantage of solving something in software versus hardware?
you don't have to open up and solder.
So let's go Y software. Okay, so maybe easier. Soldering not. Isn't that like a weird way to spell it? Like we say solder, but it's spelled like that. It's a fun word. Okay, so we can say software is easier. Even though Dane hates programming, and he probably would prefer to deal with yeah, a hot tool and some metal. Just melt it. That sounds like more fun, right? Okay. But it's not unfair to say that software is easier. Okay. What else about software?
Faster.
What do you mean faster?
I guess it's easier to install and update than go on and change your hardware.
Okay. Quicker to modify? Yeah, if we decide we want that program to work a little differently, we just go into the software, make a couple of quick little changes, recompile it, and we're done. If we decide we want to make our hardware work differently, we got to go in and solder some new things or unsolder old things. And if we put the hardware inside of a plastic container, a case, to make it, less susceptible to damage and make it look a little less geeky, now we have to get into the case. So just like fixing something inside of your wall, you got to knock a hole in the wall or take the drywall off, whatever. So it's not nearly as easy to make changes. Okay, so software is quicker to modify. Anything else from a software perspective? Let's bounce to why hardware. From this slide, it says like, well, okay, software is easier to do in the first place, and we can change it more quickly. Why would anybody do anything in hardware?
Is it faster?
Faster, performance. Software is kind of an interpreter, isn't it? Can software function without hardware? Can hardware function without software? Yeah. Hardware's the more pure version of problem solving, right? Goes all the way back to the, when we were chiseling wheels out of stone. That doesn't get any more tangible than that. Okay, so hardware is definitely faster. That's the trade-off, right? It's harder to work with, but at the end of the day, the solution is a faster solution. Okay, so why else hardware? That's it? Well, it's faster. That's about all it has going for it. That's it. That's fair enough. We could probably, sit here and fight for a little bit and come up with a couple of other little things to say. But at the end of the day, saying it's faster is probably enough. That's the big deciding thing. Do I want it easier and easier to, do I want it quicker to create and easier to modify, or do I want it to be faster and a nightmare to create, and I'm just going to start over if I'm going to modify it? Yeah.
Well, also, if there's like a certain problem or a certain solution that you need to keep answering, if you do it once on hardware, you don't have to do it for every single software program that tries to run it on hardware.
Okay.
So it could be.
So potentially more universal?
If every time you need to switch the two numbers around, you just had to do that.
Sure.
Right?
How is that different than like a method, though?
Oh, I guess you have a method built into the language, but then you have to build it into every language. So I guess build it once versus build it however many languages there are that can run on the hardware.
Well, keep in mind that the languages don't run on the hardware. The languages ultimately provide input to the hardware. So anything that can provide the correct kind of input can work. So really, creating an inverter in hardware is the same thing as creating an inverter method in software, except the inverter in hardware would be faster. Less accessible, because it's easy for us to call a method. It's more difficult for us to provide an electrical signal to an inverter and then read the output. It's not nearly as convenient. So the idea of it being universal maybe isn't fair. Ultimately, it comes back to performance. Okay. So is it fair to say that the weaknesses of hardware is that it's more difficult to originally create the solution and changing the solution is problematic? That's a fair statement. And the weakness of software is it's slower. Pun intended. It's an inverter. Okay. But hardware still exists, correct? There's plenty of things that we want hardware to exist for because human beings want speed. We don't care if the problem is harder to solve. That's somebody else's problem, right? We don't want, this goes back to the argument of Java versus a purely compiled language. We don't care. If we're writing software for Windows only, we don't care if it's platform independent. Don't give me this crappy virtual machine. I want to run on the actual CPU. Otherwise, I'm just going through this filter, slowing everything down. Now, at the same time, when you buy a new computer, you want the latest, greatest, fastest processor, right? You don't want them to take shortcuts and make it easier to solve their problem and have the processor be less powerful, slower performance. No, we don't care how complicated that processor was. And if we're tethered to the wall, we don't care how much battery it drains. We just want pure performance, right? Even as difficult as that problem might be to solve. What percentage of software applications have bugs? All of them, right? Fair enough. I think you could actually probably make an argument that it's 100%. The reason being is, so let's take a Hello World program that seems very simple to us. It's still leveraging an entire language that was written that's much, much, much more complex that's bound to have some bugs in it. So, but whatever. Just about all programs have bugs in it. Well, we already said that creating hardware lets us solve similar problems to creating software. So what percent of hardware has bugs in it? What do you think? Is it all? Is it all hardware has bugs in it? The answer is no. Why? It's related to something we just said. Would there be any bugs in that simple, assuming it worked, would there be any bugs in our inverter? Why?
Well, if there was a bug, it wouldn't be an inverter. It would just be nothing, I guess.
Okay, well, but if we wrote the inverter method and the inverter method worked, we could still say that there's potentially bugs in that program because of the underlying language, right? Where hardware gets us down to the base. It doesn't rely on anything besides electricity. So at this point, we're down to physical sciences where this isn't human being created. Electrons exist. It's a thing. So if there's bugs in electrons, well, that's not our problem. That's a God creation thing.
It's up to 6.
Man, we're just padding it at this point. Okay. So in any case, hardware in a simple case may be bug free.
So it's easy for us to say that inverter is bug-free. How complicated do you think a CPU is compared to an inverter? A lot more complicated. Like the difference between, I don't know, creating a chainsaw cello and a jet. Work that example.
I think it'd be pretty hard.
What, to create the chainsaw cello? Would you rather have to build that or build a jet? I think the
jet would be a lot cooler.
and more difficult. Way more parts to a jet. Chainsaw cello, you go out and get a cello, you go out and get a chainsaw, you somehow marry the two together with the motor and make sure the cello stays intact as the chainsaw is ripping its awesomeness. So good. Okay. So, anyways, fair to say that things like CPUs, he's searching to see what exists.
Like, Lippman might be onto something here. What do you know?
I could see it being like some old like mafia weapon or something like that.
So it's fair to say things like CPUs are really, really complex, right? I mean, would you say that a CPU is probably, the level of complexity of a CPU is probably equivalent to a pretty complex software application, right? Maybe not to the level of an operating system that has, a million different things in it, a million different moving parts, but quite possibly it's, as complicated as like a business application like QuickBooks or something like that. I mean, CPUs are not simple things. There's a lot of things that have to happen in it. So what are the chances that a CPU has bugs in it? When was the last time you heard of a CPU getting recalled? We hear cars get recalled all the time, right? For different things, different bugs that came off the manufacturing line. But have we heard of a CPU getting recalled? Why is that? Have you ever downloaded a software update for your CPU? Doesn't seem like we've done that either, does it? So, what's the scoop with CPUs?
Magical.
they are magical. What is a CPU? If you had to describe what a CPU does, what would you say a CPU is? At a little bit lower level than it's magical. Goes back to our magic tricks thing. CPU knows how to do a whole bunch of magic tricks, right? Okay, so let's say it knows how to do 500 different things. There's 500 different unique things that a CPU can do. Are each of those individual things testable? Sure. 500 magic tricks, we can test those, right? It seems like a CPU would be highly complex, and it is. It seems like it might be prone to having bugs. Outside of heat and things like that, a CPU is actually not that prone to having bugs. Reason being is you can test each one of those 500, let's say, magic tricks. And each one of those things is a very small, little tiny widget that has a very simple input and a very simple output. And it's not the CPU's job to use them in correlation with each other. The CPU just provides mechanisms for these 500 magic tricks. It's the person writing the software who ultimately says, do this magic trick, followed by this magic trick, followed by this magic trick, and oh, look, it's actually an awesome magic trick we just created. But all the CPU needed to do is perform 3 things that are very simple little widgets. Does that make sense? Okay, so part of the reason for that is CPUs are general purpose and don't solve a problem in and of themselves. CPUs provide a service. Here's 500 magic tricks that I know how to do. Call them in whatever order you want. If it doesn't work, it's your fault. Now, that doesn't mean a CPU can't have bugs, but it's unlikely with proper testing that a CPU will have bugs because each problem it's solving is like the hello world program. Does that make sense? Okay, so where things like graphics cards are far more proprietary in nature, they are solving very specific problems in powerful ways, in ways that they don't allow a programmer to handle. You know, they don't say, okay, well, whoever's writing the game, they get to decide how our NVIDIA awesome graphics card handles this in the most efficient way. Our graphics card figures that out. Does that make sense? In fact, even beyond that, we also provide them with the driver. So everything that the game designer is doing, they're doing in terms of the things the driver knows how to do. And the driver then communicates with the hardware, with the card. And if there's a problem with our driver, we update the driver, not the programmer. NVIDIA updates the driver. Their programmers do. Does that make sense? They're solving a more specialized problem. But now we have firmware come into play. So we take something like an NVIDIA graphics card. Similar to a CPU, except much more complex problems are being solved on there. So maybe an NVIDIA graphics card knows how to do 100 different things instead of 500 different things. It's actually probably far less than that. It's probably more like 20 different things. Okay, so it knows how to do 20 different things. But each of those things is a significantly more complex problem than any of the individual things the CPU knows how to do. Not because the CPU is not powerful, it's because the CPU is built to be very general purpose. It's like a general purpose programming language like Java or C# that's built to solve a whole array of generalistic problems. Whereas a graphics card is built to solve a very, very specific problem. The domain-specific language equivalent. All it's solving is the problem of making stuff appear on the screen and look awesome and happen really fast. That's the problem it's solving. Okay? So, since it's solving a more complex problem, do you think that graphics cards are more likely to have bugs in them at the hardware level than processors? Seems like that's the path I'm taking you down, right? It seems like they would be more likely to have hardware bugs. So that's where firmware comes in. How does firmware work? I mean, does firmware make hardware slower right off the bat? At the end of the day, I think everything ultimately comes back and works kind of like a CPU does. The graphics hardware itself, the actual hardware, is built much like a CPU. Here are the 300 things that it knows how to do in little microscopic widgets. Little simple little problems. Take this bit, multiply it by some value. Something like that, because a lot of what graphics cards do is floating point math. But let's just use that as an example. There's 300 little simplistic problems. The number of magic tricks that are on a graphics card, it seems somewhat generalistic, but it's not going to be as generalistic as a CPU. CPU is built for solving a zillion different problems. A graphics card is built for solving a subset of those problems in a very small domain. But it still can provide simplistic magic tricks that, when called in the correct order, can solve a problem. The firmware is software that lives directly in the hardware. Right off the bat, we should be thinking that, okay, well, at the very least, because it's software that lives right on the hardware, it should be fast. At least relative to software that lives external to the hardware, right? It's right on board. The interstate, the commute between the software and the hardware itself is very short. So it should be very quick. Okay? Even beyond that, when the card powers up, firmware is usually directly loaded into memory. And it's loaded into super fast memory built specifically for holding that firmware. So firmware is software that tries to be as close to the performance of hardware as possible.
yet being changeable, being mutable. Okay, so we can change our firmware software. And what does the firmware software do? The firmware software says, here are the 20 things that a graphics card knows how to do. And we've solved those problems in terms of the 300 mini things, the 300 widgets that a graphics card provides us. The GPU, graphics processing unit. So we've solved the problem in terms of the features of the GPU. And if we find a bug in the way that we're solving that problem, we can update the firmware. Maybe we forget to call, or maybe we call 2 instructions out of order. And under certain circumstances, bad things happen. You get flickers on the screen or something like that. And that's discovered after the card has hit the market and stuff like that. Well, now you've provided a mechanism to say, oh, well, let's go and update the firmware so that instead of those guys being called in the order they're currently being called, let's call those 2 widgets backwards. So now what we've done is we've turned the graphics card situation into something much more like CPUs. Kind of make sense? While giving us as much performance as we possibly can by moving that software onto the hardware and having it live in memory, loaded directly into memory when the hardware starts up, and have it reside in really, really, really fast, really, really, really expensive memory. And these are all things that drive the price of those graphics cards. Okay, so why don't we solve everything using hardware? It seems like hardware is faster. It seems like with firmware, we've kind of sort of solved the problem with making it changeable, right? It's still going to be slower to implement the solution, especially when you consider to minimize the bugs with hardware, we have to implement the hardware to have 300 magic tricks that it knows how to do, and all problems it solves in terms of those magic tricks. But it's always faster, and now it's changeable. So why wouldn't we solve every problem in hardware? It's like, well, you're right. Has the whole rest of the world missed the boat here? Shouldn't we all be getting our soldering irons out and building our hardware prototypes, then taking it over to some factory and having them print our circuit boards for us so it looks pretty? Why don't we do everything in hardware?
It costs more than software.
Cost prohibitive. Why software? Hardware is expensive. And here's a good example of that. How much is a brand new CPU? $200. Okay. And that's for not your fastest, but a pretty good one, right? Okay. We'll call that our average. Our average nice CPU today is $200. How much is a Java virtual machine? It's free. It's a piece of software that simulates the CPU, right? Java virtual machine. It's hardware implemented in software. Fake hardware. So using that example, hardware is 200 times more expensive than software. Is that more expensive enough? How many of you would pay 200 times more for a really, really good pizza than a decent pizza? Depends on how good the pizza is, and $200 more, 200% or 200 times more than what? If it's 200 times more than a penny, I might be willing to pay $2 for a really, really, really good slice of pizza over a free slice of pizza. But if it's a $9 pizza, $10 pizza, would you be willing to pay $2,000 for a really good pizza? It better be a good pizza. That thing must sustain you. It better be a big pizza. I wonder, why don't
This just came to me too. It'd be an interesting business model. Why don't pizza places, especially in college towns like Domino's, why wouldn't they do like an all-you-can-eat subscription?
Like,
You know, like you pay up front. You pay $2,000 for the semester or $1,500, you know, whatever they come up with a business model, and that entitles you to order as many pizzas as you want. Maybe there's up to a limit per day or something like that, so that you're not like filling parties. So it's like kind of think about Netflix, you know, kind of the Netflix model for unlimited downloads, but they only give you so many simultaneous streams, that kind of thing. But for a fixed price, because the reality is a lot of people are going to look at it and say, "Oh, well, that's a good deal," but they're not going to eat $1,500 worth of pizza in a semester, even though they think they will. Other people are going to, you know, get their money's worth out of it, but in the end, it might actually be a very profitable business for like a Domino's, because they're getting all that money up front. Same thing. Like, why doesn't like Pepsi and Coke do this? You know, go like deliver it kind of milkman style, where you're on their route and you've paid for your subscription. Your subscription gets you so many bottles of Coke a week or something like that, or you know, whatever it is, or even, you know, put in their own infrastructure of pipes, just like we have water delivered to houses. Have Coke delivered to your house. It's not a bad idea. I wonder why they wouldn't do it.
I'm sure there's some acidic stuff that will where the pipes.
Oh yeah, I mean, absolutely possible.
Coke sprouting up out of the ground.
So, but what about we have a Coke leak? You're going to avoid 4th Avenue. There's Coke mixed with 7-Up just poured out of the. Who would have thought we would have had a simultaneous burst? It's right near the plant. Just somebody drowns in 7-Up. Chainsaw cellos and drowning in 7-Up. Brought to you by Nabisco.
Should patent that. I haven't seen any pictures of it. They do a video of a guy playing a cello with a chainsaw.
Oh, that might be close enough. It might be difficult. You're going to pay money to patent something nobody's going to want to build. Like, look, I hold a patent on that. You're like one of these guys that brags on his resume. I hold over 3,000 patents. Somebody starts looking into the kinds of patents you're just patenting things that nobody would create. There was a video on USA Today yesterday of this group of people. I don't know why this popped in my head, but there's these 3 fishermen that were fishing for like marlin, open ocean, and they were fighting the fish, and the fish jumps in the boat with them. And marlin have, you know, like a marlin is a dangerous animal if you don't have control of it, because it's got like sharp stuff and a sword thing coming off the front of it. So anyways, this marlin jumps in the boat and starts flopping around, and the other guy jumps out of the boat. So he dives out of the boat.
I saw that one. It comes like up and then it comes like around the boat, and then it comes right for him, and he just jumps out.
Marlin comes in, fisherman goes out. Okay, so certainly hardware is more expensive. So we're probably, and if we use that model, that's 200 times more expensive. That's fair, right? What's up?
Unless it's Adobe.
Yeah, like you paid for Adobe.
Well, now it's all cloud-based, so.
You still have to pay for a license.
Yeah, but you can't just steal the program anymore.
Well,
You have it like on. You can't download a program anymore.
like Photoshop?
Yeah.
So Photoshop's 100% in the cloud now?
That's what I think. I don't know. CS6 was the last one that.
See, I can't imagine actually doing, you know, using Photoshop inside of a web browser or something like
Yeah, that's what I think they have it as. I'm not 100% sure, but I can't find anything past CS6. So.
that. Are you sure CS6 isn't the newest one that came out?
Yeah, I'm sure.
Oh, so there has been a new one. There's something else.
So I can't find it. I think it's all cloud. I can't get past, where it says what's your credit card number. I don't have, the $900 they want, or actually they monthly payments.
Yeah, but I think there's a student one that's a lot less expensive. Like I think that I remember reading something about it that they made it like super cheap for students. It might even be free,
Yeah.
or it's like $40 a year or something like that.
That's still a lot of money.
I don't think you might not be able to do commercial stuff with it. I'm sure there's some sort of special license or whatever, but I think it's a lot less expensive for students. But
So it's the free version.
so it was the free professional version. Done and done. Okay, so while it might make sense to do everything on hardware in a best case scenario, if we had unlimited money and unlimited time and all the technical skills we needed to solve every problem in hardware, plus with writing stuff in software, we just basically need our brains and our fingers and a computer monitor. You get what I'm saying? As opposed to carrying around this toolbox with soldering tools, and you need to run back out to Radio Shack to get these different parts, and then you got to have a manufacturer that can fabricate it for you. Because you're going to build your prototype, it's going to look all ugly with soldered wires and stuff, and then they're going to run it through a system and map it, and then print a circuit board that is equivalent to what you created. So you solve the problem in the ugly ad hoc way, and then they mass produce it in printed circuit boards. So that seems like a lot of work, right? So that's why we have software and not hardware. And when do we do things in hardware? At what point is it worthwhile spending the extra money to do something in hardware versus software? Why aren't all of our computers software-based? Down to the core. Why isn't everything above the, well, I don't want to finish that thought because it's part of the answer I'm trying to get at you. So why don't we just make everything software-based? It would drive the cost of computers way down, wouldn't it? Well, the thing that should be popping in your head is performance, right? Right off the bat. There's also a level of dependency. That is, software can't exist without hardware. So what's the minimum amount of hardware that we need in order to have software? When we think about our computers today, you're almost thinking about it in terms of that minimal amount, right? Well, we need that hardware-based brain. We need the CPU. And our operating systems have management software for that. Almost like our operating systems are firmware for CPUs. Make sense? Because we have CPU management and process management. We also need our hard drives for long-term storage. We need our memory for short-term fast storage. And then what do we have in the middle that hooks all that together? We have our motherboard. Motherboard provides all the interstates, all the highways to move data between all those things. That's kind of our minimal subset of things that we need in order for something to be a computer at the hardware level. And then we lay software on top of that for doing everything else. Does that make sense? And even today, as we start getting to these smaller and smaller machines, so for instance, I think I mentioned this and it might have been in this class, might have been a different class. If you were to open up this MacBook Air, the reason they can make this thing so tiny is it's a system on a chip. So the whole computer inside of this is probably about that big. That's CPU, that's hard drive, that's memory. All of that in something probably the size of my iPhone. Because it's all done, the whole problem is solved on a single circuit board. Does that make sense? They may have soldered a couple of extra parts on there or something like that, but you don't have these separate pieces like you do in a traditional computer. Skippy's Dell over there, on the bottom of that, I'm sure there's a little screwdriver thing you open up and put more memory in it, right? And it's not like your laptop is like horribly non-portable. It's a perfectly portable laptop, right? It's not as portable as this, but it's significantly more expandable. So he can decide, when the price of memory drops, is that a relatively new Dell? Pretty old?
4 years.
Okay, so probably your max memory is probably 4 gigs then. What do you have in there, 2?
I think so, yeah.
So he could probably decide, hey, I'm going to bump this to 4 gigabytes.
He might need to dump all the RAM he currently has in there and upgrade it with two 2 GB sticks if he only has 2 slots, which usually laptops have. So he goes out, spends his $60, gets two 2 GB sticks for that, probably DDR2 or DDR3 RAM. Opens it up, puts them in there, done. That doesn't exist for this kind of machine. If you want to do that, you need to go in with a soldering iron. I think there's a couple of parts of this. Maybe the hard drive is a insertion chip, but it's not like your normal solid state drive. Like you would not put what you bought. You have a 40 GB solid state drive, right? So, and it's the size of a hard drive, ish, right?
The small, but yeah.
Yeah, but I mean it's a full size. It's thicker than this is. So you don't put normal pieces of equipment in this. These are specialized proprietary things, which is what drives the price up. But if we take that generalistic thing where we say, this is what a computer is, it's all the crap that fits on this chip, or if you want a little bit harder performance or a little bit higher performance at the cost of having a bigger footprint, it's all the stuff you can fit on this motherboard. And then you have a hard drive coming off of it and all that stuff. That's what your actual computer is. Then you lay the software on top of it, which is the operating system, and the operating system talks to that hardware in terms of the things that we've discussed in this course. CPU management, process management, memory management, drivers, file systems. That's what the operating system does. It lives on top of that and translates everything for those generic parts that says this is what a computer is. That kind of makes sense? So now we want to start talking, transitioning this into different types of operating systems. Desktop operating systems versus server operating systems. And then when we get into server, we'll talk about traditional server versus distributed operating systems. So just at our high level in our last couple minutes here, what is a desktop operating system? What are the characteristics of a desktop operating system? So kind of like our little comparison between software and hardware. What problems are desktop operating systems trying to solve? I'm going to start at high performance for a single user, let's say at a time. Because most of our desktop operating systems, they'll allow you to log out as one user and log back in as another, but you only have one dude using the machine at a time, right? Okay? So desktop operating systems focus on providing an experience for one user at a time. What else? What else might the focus of a desktop operating system be in terms of all the stuff we've discussed up to this point related to operating systems? Now, what about software applications? Do we have a different expectation for available software applications for a desktop consumer-based operating system versus a server operating system? Mucho software.
Did you almost say the same thing about hardware then?
I think it's definitely fair to say. Mucho hardware. I was going to try to spell abundance, and I decided let's just keep it south of the border. What's up?
Olay.
Olay. Que bueno. So lots of software available, lots of hardware support. Correct?
That goes along with saying like a lot of options. Like there's so many different brands of computers and stuff.
So maybe less proprietary?
We want consumers to have as many options as possible for accomplishing what they want to accomplish.
And would that also drive the kind of cost down since there's so much?
Yep. Low cost. Low cost, high performance, lots of software, lots of available hardware, not proprietary. All right, so I'll just create our next slide and then we'll call it quits for the day. So we'll start off next time talking about server OS. Make sense? All right, I'll see everybody on Wednesday.